Hey guys, we're going to start today's lesson on simplifying algebraic expressions. So, to start us off, we need to look at a little bit of vocab. First vocab word that we have here is term. A term is each part of an expression that is separated by addition or subtraction signs. So each little section of the expression is called a term, and each term is separated by either an addition or subtraction sign. Next, we've got constant. Constant is a term without a variable. Coefficient is our next one, and that's a number that is being multiplied with a variable. And then we have constant. Constant is a term that doesn't have a variable. And last, we have like terms. Like terms are terms that have the same variable or that are both constants. Now, if you don't understand what these are, I think you'll understand if we look at our next slide because it's going to show us kind of an example and help us to explain these a little bit better. So let's start here with a term. A term is just each piece of an expression. You can see that in this particular expression, we have three terms. The first term is minus 4x. Then we have a plus sign separating it from the next term, which is 12. And then we have another plus sign that helps to separate again. And we've got an x. So we have three terms. 1, 2, 3 terms. Next, we have a coefficient. Coefficient is, like we said before, the number that is being multiplied with a variable. So in this particular term, the coefficient is -4. X is not part of the coefficient. Okay, the coefficient is just the number that is being multiplied with the variable. So the coefficient is the -4. It's not -4x, it's just -4. Okay, a constant is a number that doesn't have a variable. So here we've got the term 12, and 12 doesn't have any variables with it, so it is called a constant. Next, we've got an x. This is just an x all by itself. It doesn't have a coefficient because there's no number being multiplied with it. It's just the variable x. Now, our last term that we had there was like terms. And like terms are any terms, so notice we've got three of them here, any terms that have the same variable. So we have two like terms. We've got -4x and x. They both have the variable x, and so they are like terms. So let's look at one more quick slide here. Now, one thing that we can do with like terms is we can combine like terms, meaning put them together. So terms in an expression that have the same variable can be combined. For example, if I have an expression like 4 times z minus z, both terms in this expression have a z. The sign between them is subtraction, so you can subtract the terms. Now, if a term doesn't have a coefficient, like this z right here doesn't have a coefficient, it doesn't have a number in front of it. Well, if it doesn't have a coefficient, then the coefficient is 1, meaning this would be like 4z minus 1z. Well, if I have 4z's and I take away 1z from it, that leaves me with 3z. So my simplified expression after combining like terms would be 3z. So I'm going to go ahead and close out this little thing that we were using for our vocab. And let's go ahead and take a look at some problems. So our first problem is going to be 6n minus 7n minus 4 plus n. Now, the first thing I want to do is make sure that we understand our vocab. So on our vocab, how many terms do we have in this problem? Well, I've got 6n, and it's subtracted by a minus, or split up by a minus sign. Then I've got another term, 7n. Then I've got another subtract sign that breaks it apart. Then I've got the constant 4, and I've got another n. So I have total 4 terms in this expression. Next, I want to see, okay, so I've got these. Next, I want to know what numbers I have that are coefficients. Well, coefficients are numbers that are being multiplied with a variable. So I'll start from my first term. I've got 6n. Well, 6 is a coefficient because it's being multiplied with n. Then on my second term, I've got 7n. Well, I've got 7 is being multiplied with n, so that's a coefficient, 7. 4 does not have a variable, so it's not a coefficient. N doesn't have any numbers in front of it, so it has no coefficients. So the coefficients in this problem would be 6 and 7. Now next, let's talk about constants. Do I have any constants in this expression? Well, 6n minus 7n minus 4 plus n. This one doesn't have a constant because it's got a variable. Also no constant because there's a variable. But 4 is a number all by itself, so yes, it's a constant. So my constant in this one would be 4. And finally, do I have any like terms? Now remember, like terms are any terms that have the same variable or that are both constants. So I notice that my first one, 6n, has an n. Notice my second term also has an n. The third term does not have an n, so it's not a like term. And the fourth term also has an n, so yes, it's a like term as well. So I have 3 like terms. So if I was making a list of my like terms, I'd have 6n, I'd have 7n, and I would have also n are my like terms. Okay, so that's just a quick review on the vocab. Next up, let's actually start simplifying some expressions. So if I want to put my expression in simplest form, I'm looking for like terms that I can combine. And let's say my first one here is one like this. I've got 7x minus 2 minus 7x plus 6. The first thing I'm going to do is I'm going to combine like terms. Now, in order to combine them, I've got to first figure out which ones are like terms. So I start with my first term in the expression, that's 7x. And I notice it's got an x. And as I look through my expression, I notice that I have another one that has an x as well. Okay, so those are like terms. Now, if I'm looking through, I can see that I've got other terms here. 2 is a constant, and 6 is also a constant. So those ones would be like terms with each other. Once I've identified my like terms, then I can start working to combine those like terms. So I've got 7x, and I'm going to combine it with my 7x here. Now, here's how I know what to do with them. If I want to know if I'm supposed to add them or subtract them, I look at the sign that's in front of the second term. So I have 7x here, and my second term is 7x. And if I look at the sign in front of it, it's a minus 7x. So I've got 7x minus 7x, which just leaves me with 0. Now my second set of like terms were my 2 and my 6. Now notice though that this 2 has a minus sign in front of it. That's like having a negative. I've got basically negative 2, and I've got my 6, the sign in front of it is a plus sign. So basically that's telling me I've got, wrote down the wrong number, sorry, negative 2 plus 6. Well, signs don't match, so I'm going to subtract them. 6 minus 2 is 4. I take the sign of the bigger number, the 6, so I've got 4. So now that I've combined those two things, my x's combined and got me 0, and my negative 2 and 6 combined to get me 4. So I've got 0 plus a 4. So now when I've got it totally simplified, my expression is just 4. And then I'm done. That's my answer. 4 is my simplified expression. The x's canceled each other out, so I don't have any variables left, and my overall expression is just 4. In this example problem, we have 2g minus 3 plus 11 equals 8g. And so let's start by combining our like terms. In order to do that, we first got to identify our like terms. I've got my first term is 2g, so I look to see if I have any other terms with a g, and I do. I've got my other one right here. So let's go ahead and combine these ones first. I've got 2g, and I've got a minus 8g. So I've got 2g minus 8g. That would get me, well, let's see, 2 minus 8 gets me negative 6g. Now I look to see if I've got any other like terms in the problem. I've got a negative 3 and a plus 11. Those are both constants. That means they are like terms. So I've basically got negative 3 plus 11. Signs don't match, so I subtract. That gets me 8, and I take the sign of the bigger number. 11's bigger, so it's a positive 8. So I've got my minus 6g, and I've got a positive 8. So that would mean I'd write it like this. Negative 6g plus 8. And that's my final expression when it's been simplified. Here's one more example. Let's go ahead and simplify this expression. So I'm going to start by finding my like terms. I've got a 4p and a 6p. If I'm going to combine those, I've got 4p, and that's a plus 6p. So 4p plus 6p is going to get me 10p. And I've also got another set of like terms. Okay, I've got a negative 7, because I think of that minus sign like a negative sign. So negative 7, and I've got a plus 10. Well, let's see, signs don't match, so I'll subtract them. 10 minus 7 is 3. Take the sign of my bigger number, that's a positive 3. So I put this here, or put it back with my other term, and now my final expression is 10p plus 3. And there's my final expression. Let's try one more example, and in this example, we're going to be doing something that we learned yesterday, distributive property, and combining like terms. So on this problem, you'll see that we've clearly got a distributive property problem right here. I've got 2 times y plus 3, but then I've got this extra term here out on the end of minus 4y. So to solve this problem, I've got to start by doing the distributive property. I'm going to get rid of the parentheses by using distributive property. So I'll do 2 times the y gets me 2y. And I'll do 2 times the 3 gets me 6. They still have the plus sign between them. And then I've still got my last term, 4y, here at the end. Now that I've used distributive property and got rid of my parentheses, I can combine like terms. And I notice that I've got 2y and 4y are like terms. So I'm going to combine them. 2y, and this is a minus 4y. 2y minus 4y, well, if I have 2 and I take away 4 from it, that's going to get me negative 2y. Now notice that the 6 doesn't have any terms to combine with. It's just by itself. So if it's left over, I'm just going to put it on the end of my expression. It stays there because I didn't do anything to it. After I combine my y's, I got negative 2y, and I still have the plus 6, so it's coming down here and being put on the end. So my final expression is going to be negative 2y plus 6. One final example. This is putting a little more application onto it. We're mixing in a little algebra and geometry. Here I've got a picture of a quadrilateral. And this quadrilateral has sides that are 9, 19x, 18, and 7x long. Now, let's say I wanted to find the perimeter. I can't actually find the perimeter because I don't know what my x value is, but I can write an expression to represent the perimeter. Now, perimeter is found by adding up all of the sides and putting them together. So I could write an expression for it. My expression would look something like this: 19x plus 18 plus 7x plus 9. Now I've got an expression to represent my perimeter. I could say P or perimeter equals 19x plus 18 plus 7x plus 9. But you'll notice that this is a really long expression. And I've also got some like terms in it. So I could make it simpler by combining those like terms. So I've got 19x and 7x. 19 and plus 7. So if I do 19 plus 7, that's going to get me 26x. And I've also got the constants 18 and 9. Those are like terms. 18 plus 9 would get me 27. So that would be a positive 27, so I would say plus 27. So my simplified expression for the perimeter would be 26x plus 27. And that would be the expression that can represent the perimeter of this quadrilateral.